Hi everyone, and welcome to the first physics video for Launch Learning Platform. So how these videos will work is that I'll be taking you through the entire physics CSEC syllabus in order. And so what that means for today is that we'll be starting with mechanics and specifically physical quantities. Okay, so before we get started, I kind of want to give a bit of background about the physics syllabus in general. So it has 5 different sections from A to E. And since we'll be going in order, of course, we're going to start with section A, which is mechanics. So within section A, there are 6 different topics that we want to cover. The first being physical quantities, which we're going to do today. And what physical quantities are is basically the building blocks of physics. So what are different quantities involved? What are their units? And we're going to look at all of that today. So once we're done with physical quantities, we'll get into vectors. So now that we have our building blocks, what happens when they start interacting? And vectors kind of tells us, what happens to their magnitude, what happens to their direction. And then after that, we'll get into statics. And so once we have our kind of the magnitudes and directions and understand how those work fundamentally, we're going to apply them to different systems. Systems just mean objects like boxes, cars, bicycles, things like that. But the important thing about statics is that our system is not moving, so it's static. Then once we're done with statics, our system starts moving. So we move on to dynamics, which is kind of everything I just said, but now our system is in motion. And then once we're done with dynamics, we move on to energy, which just means looking at the different kinds of energy involved with our system, both in static and dynamic situations. And we'll get into all of that. And then once we're done with those first 5 topics, we'll kind of move into hydrostatics, which means applying those kind of same concepts, but now we're looking at systems that have either water surrounding them or in some cases, like just different kinds of fluids. Okay, so let's get right into it. So where I like to start with physical quantities is just looking at a definition of physics. So physics is a subject matter that combines a lot of different areas, but they kind of break down into 2 very important pieces, matter and energy. So matter just involves anything in our environment that has mass or takes up space, just like any object. And when we start looking at energy, I hope you remember from, third form or second form that energy is the ability to do work. So when we're looking at these 2 areas, we're looking at how we can define and describe the world around us, which is the matter and the energy that these objects and the world around us possesses. But that's at a very high level. Basically, the most important sentence that I want you to remember today is that most of the answers, these answers meaning like how we take matter and energy of different systems and how we look at them and how they kind of tell us or define different things happening in our world. Most of the answers for these kind of problems that we start thinking about, which any physicist can give us, boil down to information about a few fundamental ideas. So I know what I just said might have been confusing in terms of like matter and energy and all these things, but that's kind of the higher level stuff. Now we're just looking at a few fundamental ideas, and those are a lot more simple to think about. So there are 7 of them, and we call those our fundamental quantities. So let's list out the 7. So we have length, we have mass, we have time, we have current, we have temperature, luminous intensity, which we won't really look at that much, and just the amount of a substance, which is basically the chemical makeup of a substance. You look a little bit more of that in chemistry. But these are the 7 most basic ideas that we can use to kind of allow them to interact with each other, allow them to define objects in our world, allow them to tell us at a higher level. So when we start thinking about like energy and matter, what is going on in the world around us. So again, these are called our fundamental quantities, or as you might see sometimes, base quantities. So the important thing to remember about these quantities is that they have units, right? So, and of course, the name that would be attached to this would be the fundamental units. So if we go back through our list and we look at length, our fundamental unit would be meters, and that's normally represented by M. If we look at mass, that's going to be the kilogram, which is normally represented by kg. For time, that's seconds, which is an S. Current, that's the ampere with a capital A. Temperature is Kelvin with a capital K. Luminous intensity is the candela, which is represented by common C, common D together, and the chemical makeup of a substance is moles. So that's represented by MOL. And like I said, we'll kind of dive into the moles a little bit more in chemistry, but not quite in physics, right? So again, these 7 fundamental quantities are what we use to get information about the world around us. And what that means is that these fundamental quantities are the building blocks for how we get all other physical units. It's what we use to derive, and let's remember that word derive, all other physical units. So let's look at some examples of how we can take our fundamental quantities and derive some units that we might be more familiar with. Looking at like area, for example, if we have length times width, that width is technically also a length, right? So we end up with length times length. And if we go back to what our units are, we know that would be meters times meters. And so our unit that we end up getting from our fundamental units would be meters squared, right? But it doesn't just stop there. We can keep building up. So this is just like a kind of simple example of combining one of our quantities to just give us a larger representation of something around us. So in that case, that was area. But if we keep going, we can get volume. Like if we have length times width times height, that would be length times length times length, because width and height are length. And we end up with meters times meters times meters. And so that ends up with our kind of more complicated unit, which is meters cubed. Okay, so just to reiterate, what did we just do, right? We took our fundamental quantities and we got what are called derived quantities. So we started with our length, which is, like we described above, a fundamental quantity, and we ended up with something more complicated to tell us about the world around us. And that, in this case, was our meter squared, which is our area, and our meter cubed, which is our volume. But it doesn't just stop there. Like if we wanted to start with our volume or start with area, we could also break them down into our fundamental quantities. Okay, so let's try to think of a more complicated derived quantities. So I know we've often heard of speed, right? You know, how fast the car driving, how fast the bus is going, how fast you're riding a bicycle, all of these things. Well, basically what speed is how far you travel in a given amount of time. And that's often represented as, if we look at our units, a certain length over a certain amount of time. And if we go back to our fundamental units that these quantities represent, that would be meters over seconds, right? And so that means that our derived unit for speed would be meters per second. So let's pause there for a second. So we just took 2 fundamental quantities, length and time, and we combine them to get our derived quantity. That's basically the whole idea. We start with our building blocks, we start with our fundamental quantities, and we get something more complicated. So let's look at some other more complicated examples. So you might hear of acceleration, you might hear of force, and what acceleration is the change in speed over time. And if we look at what we just did, we know our unit for speed is length over time. We know that if we just divide that by time again, we're going to end up with meters per second divided by second. And that gives us m over s times 1 over s, which is meters per second squared, right? So that is our more complicated unit, our derived quantity, and that is what represents acceleration. So if we look at force now, so we'll define force a little bit later in our mechanics kind of journey, but force is mass times acceleration, right? And if we look back up, we know that our fundamental unit for mass is kilograms, and we just calculated our units for acceleration, which are meters per second squared. So if we take those and we multiply those, we end up with kilogram meters per second squared. So kilogram meters per second squared is kind of a mouthful. Like I wouldn't want to have to say that every single time. And so what it is often called is a Newton. You may have heard of Isaac Newton, but basically 1 kilogram meter per second squared is equal to 1 Newton. And 1 Newton is equal to 1 kilogram meter per second squared. So guys, that's the end of our lesson. And just to kind of go over what we just covered, we started with a definition of physics, which is that physics tells us about the world around us and how matter and energy are interacting constantly around us. And we know that there are a few fundamental ideas that kind of make up the building blocks for what physics are. And what those ideas are length, mass, time, current, temperature, luminous intensity, and the amount or chemical makeup of a substance. And we can't, of course, forget that these are called fundamental quantities or base quantities. So with these, they have their units associated with them. For length, it's the meter, mass, kilogram, time, seconds, current, ampere, temperature, Kelvin, luminous intensity, candela, and amount or chemical makeup of a substance, moles. So something that I kind of want to pause here and say is that you might, in your lesson, learn to have called these SI units. So that's also exactly right. So fundamental, base, or SI units all mean the same thing. So SI unit stands for System International. I think it was the French who came up with it, but basically they all represent the same thing, which are our 7 fundamental quantities that we use for our building blocks of physics. So again, we take, like with area and volume, we took length and we made it tell us about area and volume. With speed, we took length and time and made it tell us what a speed is. With acceleration, we took length and time and another set of like time and made us tell us an acceleration. With force, we took a mass and an acceleration and have it tell us a force. So the idea here for physical quantities is that we're taking these base units, these SI units, these fundamental units. Again, remember, all of these mean the same thing, and they are telling us about the world around us. So we take those 7 units, we multiply them, we divide them, and we get more complicated representations of the world around us. And of course, we can do this backwards. So if we take a speed, we can also break it down into its fundamental units. So that's the lesson for today. In our next lesson, we will take these units and start looking at vectors. And don't forget to like, comment, subscribe if there's something that you want us to clarify. If you have any more questions, please just let us know. We really are just here to kind of make education more accessible. So that's it for today. Thank you for your time.